Right? We're expecting Rajdeep to take this course. But anyways, we have swapped, so I am here. So as we'll see that it is basically two courses combined together. The reason is that I think many of you are aware of that the new curriculum is starting from this time. So in the new curriculum, all the courses will be in the level of 7,000, 8,000, for undergrad 1,000, 2,000. So that's why to enable new students means PhD and a master students who have joined this time, there is a course code with 7,900. So they are going to register for that course. And for everyone else who joined before 2025, you are going to register or you have registered for the 800 level course, right. Now, there is one more change. The 800 level course was called product design and decision or something like that, right. Whereas the 7,000 level course is called reliability analysis and reliability based design. So the course content will better suit the title I have written here, which is the 7,000 level course. So that's why I have written only that title. In general, there is no product, first of all, there never was. There is only techniques and algorithms for reliability analysis, and that is what we are going to cover in this course. Okay. So today I will not do much. I will basically introduce you to the modalities and maybe some high level motivation about what is reliability, what we are going to cover, what does it even mean, and all of those things, right. And obviously we will be talking about course policy. First of all, the course timing is Monday, Wednesday and Thursday, and this is a useless timing, Monday and Wednesday from 11 to 12 and then Thursday 12 to 1. So, it is very confusing. So, keep that in mind, and I only allow until 5 minutes after the course starts. So, if it is starting at 11, do not enter at 11:06, okay? Just do not enter, I will not allow, okay? And if it is starting at 12, same story, just do not bother me, I will not allow, and that will not change, okay, under any circumstances. Okay, there was class, there was an accident, miss that class. I am recording it, the video will be available, go and see that. You will not get attendance for that and you will not be allowed. You will not miss anything as such because the recording will be provided. So, that is not a problem, but you will not be allowed. Okay. The one more thing I will talk about, attendance policy, institute attendance policy. 75% below that, 1 grade, that is all. Nothing from my side, whatever is the institute thing, I will follow. Okay, so with that being out of the picture, let us start, right. So, what you see at the top is the website, the course website. That is where the lecture videos will be uploaded, that is where the notes will be provided, that is where the homeworks and assignments will be provided, and everything will be provided. Okay. So, that is kind of your one stop solution for everything that relates to this course. Okay. So, and that you can obviously get from my website, go to courses, you will get it, but if you want to take a picture or note it down, you are welcome to do that. Now, obviously the course will be offline, nothing online, but we are recording it, and since we are recording it, the videos will be made available. Okay. So, that will be made available hopefully as soon as possible, but sometime it might be delayed by a week or so, okay. But it will be made available to everyone. Okay. The lecture notes will be uploaded regularly, again on the same website. For any doubts, do not hesitate, just write an email. If you want to meet me, you do not need an appointment, just drop by. If I am busy, I will give you some time at my office. Okay. But mostly if you come, I will maybe ask you to wait for 5 minutes and then listen to you. Okay. So, feel free to drop by in my office or write an email. I am generally punctual with replying to emails, and I am generally punctual with responding to queries, right. So, yeah. Assignments will be there, term project will be there, and I will come to the, I will cover the details in a short while. So, assignments, term project, and what that mean, I will come to that, but everything will be, submission will be on Moodle. There will be hard deadlines, maybe a few hours I can give, but not more than that, so keep that in mind, and the deadlines will be provided today itself. So, okay, and which means I am providing it today means they will not be changed. Yeah, and the slot I already talked about it, Monday, Wednesday, Thursday, each slot basically whatever it stands for. Okay. This room might change. I have asked the timetable in church that this room might not be adequate because the registration right now is 39, including the 2 codes, okay, 35 plus 4 right now. So, and this capacity is, I mean, at least on paper it is 32, in reality it is generally less than 32, whatever they say it is generally less than that, 2 or 3 seats. Okay. So, the room will probably change. I don't know where, I don't know when, but most probably it will change, okay, and that will be communicated to you. Okay. The most important part probably for you, the evaluation policy. So, there are primarily 4 components. Okay. There will be homework, and we will be providing you with 4 homework at least, and why I am saying at least will become clear in a short while. Okay. And the total weightage of the homework will be 30%. Okay. For each homework you will get 2 weeks time from the date the homework is provided to you. And there will be programming kind of questions for which you can use either Python or MATLAB or something else. It is fine. It is a programming language of your choice. I don't mind as long as it is correct. If it is wrong, you will not get marks. So, up to you. But there will also be theoretical portions, derivations, and those you have to write by hand. Typed submissions will not be entertained. You can write on your iPad, that is fine, but typed on Word or LaTeX will not be entertained. You have to write it. Okay. Obviously, programs will be on computer, you will not write the programs. One thing I will add here, and this is a common confusion. So, suppose there is a question in the homework which is about programming, it is possible, right? And you wrote a very nice program, it is giving results, you submitted it, you will get 50% of the marks, because you are supposed to also explain the results. So, put those results and then explain those, what does it even mean, why do you think it is correct, if it is wrong, why is it wrong, what you should do to improve. So, each answer or results you are getting from your computer code that you have written, and that I am assuming that is 100% correct, should be accompanied with discussion. And this I am talking about homework, there is no practical, so I will not talk about that, so only homework, right. And as I said, the homework will have 30% weightage, which means there is significant weightage on the homework, which also means you will realize that each homework I am giving 2 weeks time, you will not be able to do it in 1 week. So, it will be having so much content that it will demand 2 weeks or at least 10 days time from you, even when you are working in group. And discussion working in group is fine, but your submission should be your own. If it is plagiarized, there is a significant penalty, which might, so suppose there is plagiarism in one of the homework, I might even make the whole homework marks equal to 0. So, do not plagiarize, and when I say plagiarize, copying from each other is a plagiarism, copying from internet is a plagiarism. From internet, if something is allowed, that will be mentioned in the homework sheet that is provided. And if something is not mentioned, you are confused, ask me, do not assume. If you assume, you are taking the risk, so if there is a penalty, you have to pay that. So, please ask if you have some confusion. Okay. Moving ahead, the next portion is term project. I will talk about it in a separate slide, but that also has 30% weightage. Okay. So, term project has 30% weightage, homework has 30% weightage. So, overall 60% is in kind of in take home kind of or take hostel kind of mode, right. Homework you are doing at hostel, term project you will be doing at hostel. So, 60% is what I am talking about, and that is kind of in take home kind of mode. Okay. What more about term project I will be talking about later, but obviously even in term project, you will not doing a single project. There will be groups will be formed and each group will be given a different project. Okay, so it will not be a common project. And then the remaining 40%, minor 15%, major 25%. Most probably I will be taking the minor and major at the scheduled time. Sometime I take it earlier, but this time I am planning to take it on the scheduled date as decided by the institute. The duration may be 1.5 or maybe 2 hours. I will decide that. I don't know right now. Okay, that will decide based on the length of the question, right? Generally, questions will be lengthy. I am telling you now only, and you might not be able to answer. You are allowed today. From next day, will be thrown out. Okay, if you are coming at 15 minutes late. So minor is 15%, major is 25%. So that covers the total 100% of the weightage. Okay. Homework, I already talked about it. There will be theoretical questions involving derivations. There will be programming questions, practical questions involving programming. I already talked about that programming. You can use your language, programming language of choice. Okay, no problem with that. There will be 4 homeworks. I talked about it, and you can see the deadlines. The first one will be on, just after Independence Day, we will provide the first homework. And then you will realize that the second homework is provided even before the first homework submission is due. And there is a reason for that. I want to give 14 days time, but I don't want to encroach into the minor time, which is 12th of September. So that's why that has been done. And then homework 3 and homework 4, even between homework 3 and homework 4, you will find a gap. The reason for giving that gap is that if I give it earlier, some of the portions might not be covered in the lecture yet. So to account for the fact that things that are covered later can also be provided in the homework, this has been done. There will be one bonus homework that will be provided to you. So if you missed something, one homework you could not do well, that is your chance to make up for that. But bonus, since it is a bonus homework, the difficulty level you can expect to be 5 to 6 times more than the normal homework. And that is why you are seeing 1.5 months of time that I have given. Almost, right, 1 month and 10 days kind of time. So there is a reason. If you see that 2 weeks have become 1 month, there is a reason for that. It will not just happen just to accommodate anything. This is happening to accommodate the difficulty level of the homework. Okay, but that is again, remember that if you are doing all and then doing that, you can potentially get more than 100 in 100, right? And if that happens, I will be the most happy one. That means that at least you have learned something, right? You have learned everything probably. But that is the original purpose, is that it is possible that one of the homework you did not do well. So that gives you a chance to make up for that. So that is the original purpose. But if you are doing everything well, scoring more than 100, you and me will be the most happiest one. Okay, others might not be happy in the class, but you and me will be. Okay, so that is the whole idea of this bonus. Okay. Okay, one more thing I will tell. So suppose let us take homework 1 for example. So it will be announced on 16th. It might have questions that has not yet been covered in the lecture, but definitely those questions will be covered by, let's say, 28th or 22nd. So let's say homework 1 has 5 questions. So 4 questions obviously will be what has been covered. There might be one question which is yet to be covered, but that will definitely be covered at least 1 week before the deadline. So don't expect that I have done everything and then that is what I am providing in the homework. That might not happen. So some of the questions might seem like Chinese, okay, because that is not yet covered. So you are like, what is this, right? Term project, and this is very important, and I have made slight changes from what I do usually. So generally, I ask the students to come up with their own project. That is being changed. We will decide projects, we will float projects, you will select. Okay. Project team I have probably not mentioned here. So each team can have maximum of 2 members. That means you can either work alone, which is fine, or you can make a team. Okay. In case you have a project in mind, you need to tell it to me by July 31st. So that flexibility I am giving you, because the projects will be announced on August 5th. once it is announced, I will not entertain any new project that or idea that you come up with. But if you come to me or email me or communicate to me in some way before 31st of July, and if I think that is relevant to the course, that might be one of the project and that will be allotted to you. So, that freedom is there, but only until the end of this month. Okay. But definitely that has to be related to the course, it cannot be some random project. Like for example, I will give you one example, even your BTP or MTP project, I am happy to accommodate them if that has reliability component or if you are bringing reliability component into that. But if that reliability component is not there, I cannot accommodate that. The course will not permit. Okay. But if it is there, that will be accommodated, no problem with that. Okay. So, that is like one thing. Now, in the okay, so I said I have changed it. So, I said that I will provide topics and I will also provide relevant papers, not a paper, but papers that does not also mean 10 papers. Papers mean 2 to 3 papers, not more than that. Okay. That I will provide and I will say that this is relevant to you, and I will meet each group individually once they have decided once and tell them what is expected of that project. I mean, what is expected, what is the best outcome that can come out of that project, right? That I will do. Now, what is your task? Not the outcome, but task. Your task will be to read those papers, understand them, summarize them. So, that will make the literature survey, even the references in that those papers, that will make the literature survey. And then by combining them, come up with write your own code, basically use the algorithm to solve the problem that has been assigned, and based on that write a report, make slides, make a presentation. So, everything that you can potentially be there is there. Okay. So, yeah. So, announcement for projects will be on 5th of August. Finalization of the topic will be on August 10th. And it will be first come first serve, okay? Because if you have decided first, you should get it. I cannot prioritize anyone that you are better, you are not better. I cannot do that. The only priority I can give is that you have come up with your own project before 31st. In that case, on 5th itself, that along with the project, you will see your name beside that. That is fine, frozen. That is the only priority you can have. After 5th, it's first come first serve. Okay? So, I will create a Google form and based on that. Will do. Okay. So, finalization of the project is on August 10th. First report submission is on September 5th, and that will be reading the paper. You have read the papers, you have summarized that, you have done a literature survey, no results is expected, that is not possible on September 5th, but September 5th will be your first submission. Second submission October 1st, and that is like a progress kind of thing. You are working on it, your code is not working, do not worry. If it is not working, why is it not working, you should mention that. What are the potential solutions you are thinking of, you should mention that and make a submission October 1st. Okay. And the final report is on November 10th. In final report, along with the report, you should submit the code / software, whatever you have developed, a README file, everything should be in its raw format, so Word or LaTeX, whatever you have done, along with the PDF, obviously. The format will be provided to you for the final report. Others, you can use your own format. For the final report, we will provide the format. There is a page limit of 6 pages, excluding references. Okay, and proper plagiarism check will be done, Turnitin and all those things, so be careful. And yeah, and after that there will be a final presentation, which I have planned somewhere between 11th and 14th. So that means the last working day, last class is 14th, if I am not wrong. So that means you can imagine that last week of the class lectures will be for presentation, where everyone should attend. Okay, so you should also listen to what your colleagues and friends have done, as simple as that. Okay. And I think 14th is the last working day. After that, the major starts from 17th, if I am not wrong. Okay. So that is, so if 14th is the last day, I am assuming 14th will be Friday, although it is IIT Delhi, you cannot, classes are starting on Thursday, so you never know. Okay, it might be a Wednesday, I don't know. Okay, so I don't know what is November 14th, but whatever is the working day before or in that week, it will happen. And if there is no working day in that period, we will book a Saturday or something, and a day long event we will do for this presentation. Now remember, each of these components will have marks. So there is 30% marks in your project. Now that will be divided not equally, but among these 3 reports and presentation. So there will be it will be divided into 4 parts. So it's not only based on the final. If in the final report, if that is a Nobel Prize and the other 3 are missing, you will get maybe 1/4 of the marks. I don't care if it is Nobel Prize. It's about consistency. Okay. So yeah, keep that in mind. Books. So I will not follow any particular book, but these are the 3 books I like in this area. So it is a good idea to have at least one of the, either the first or the third book, I will say. So first or the third book, I will say it is a good idea to have that. The second book is a little bit advanced, and those topics will actually not be covered, to be very honest. But it has other topics which might be covered, like stochastic finite element analysis is a little bit advanced topic. That I will not cover, but I have written that book because you might choose, or one of the project might be in that area. Okay. Excuse me. Hello.
Sir,
I don't care. Okay. So, okay. So, yeah. So one of these 3 books you can keep. The project you might select from the second book before 31st of July, or I might give one of the project from that. But potentially I will not. This might become a little bit too difficult, because it involves finite element coding plus combining that, so little bit difficult, I might not give. Okay. Syllabus. So obviously the course is about reliability, structural reliability, system reliability, product reliability, everything about reliability. But the primary focus will be on reliability analysis approaches, so that you can use those approaches for whatever system you are interested in. It might be a car, it might be a building, it might be a bridge, it might be an aircraft, it might be your computer, it might be a machine learning model. Okay. So, and we will also talk something about machine learning models. So, we will see that reliability analysis of machine learning models and machine learning for doing reliability analysis. So, both of this is 1/4 of this course will cover there, right. There is a approach on surrogate based approaches where this will come, but we will not go there immediately, that will towards the maybe after minor. But we will start with overview of structural reliability. We will spend significant amount of time on statistics and probability. And after doing a thorough review of statistics and probability, which might be 3 to 4 or even 5 lectures, we will then start with actual reliability, where we will talk about limit state function, performance function. We will talk about form, which is first order reliability method. We will talk about FOSM, which is first order second moment method. We will talk about SORM, which is second order reliability method, and we will talk about HORM, which is higher order reliability method. And all of these are based on Taylor series. So, Taylor series in multivariate, if you have forgotten, it is a good time to revise that. Prob and stat, if you do not remember, it is a good time to revise that, because reliability is all about probability and statistics, that cannot be avoided. Okay. So, and this methods, Taylor series based approaches, we call it analytical approach, although it is not exactly analytical, but that is one of the names that is used. After that, we will go into simulation based approaches, and this is partially where machine learning starts, because for example, Monte Carlo and importance samplings, these are also covered in probabilistic machine learning, but here we will be covering this for doing reliability analysis. So, there is a subtle difference there, and that you should keep in mind. And then there is, for example, subset simulation. Subset simulation is not covered in machine learning, but subset simulation uses metropolis testing algorithm, which is covered in machine learning. So, there is a very close connection that you will realize the moment I go into this area. And then third is surrogate based approaches, and that is where machine learning comes into picture. Surrogate model means emulators, simplified model, replacement model, and those replacement models are generally based on machine learning. Now, obviously, I will not cover all machine learning techniques, I will only cover some machine learning techniques, the supervised one to be more specific, and even in the supervised one probably I will not, it is written neural network, but I will probably not cover neural network, but I will definitely cover Gaussian process, for example. I will cover polynomial chaos expansion, linear regression, maybe ANOVA decomposition, I will see. Okay. But yeah, some of those things will be covered in details, and that is where you will see how you can use machine learning for doing reliability. Okay. And after that, so until this point we will be primarily be focusing on what is known as component reliability. So, you have a component, whether the component is reliable or not. What does it even mean? I will come to that. After this point we will go to system reliability. System is something which comprises of multiple components. Each component may fail, but failure of one component need not mean that the system has failed. You can imagine series and parallel kind of thing. So, where in one case failure might mean failure of the system, in other case it might not mean. So, we will go into system reliability, there we will talk about fault tree, and we will talk about system and series system k out of n, series and parallel system and k out of n system. And then we will go into reliability based design optimization, where we will use reliability, but couple it with optimization to design system, to design structures, to design components, so as to ensure it is optimum, cost efficient, while it is safe. So, you can make the most efficient one, but if it is not safe, you cannot use it. You want the most efficient, cost efficient one, but while ensuring certain level of reliability. Just imagine you are designing a nuclear reactor. If it is not safe, millions of lives will be lost. So, you need a nuclear reactor, you want to design it economically, but while ensuring safety. And for nuclear reactor, I will just give you a number. The probability of failure is generally in the order of 10 to the power minus 15. That is like you are designing for 100 years. It should not fail even once in 100 years. That is what you are looking at. Okay. So, we will talk about reliability based design optimization. Okay. And lastly, if time permits, or very briefly, I will talk about time dependent reliability. Now, every reliability by definition is time dependent, but until this point we will not go into that. We will just talk about techniques and all those things, and here I will just briefly talk about how you can use it for solving time dependent. Why is time dependent important? Because you can imagine, right, think of this building or something, with time the material degrades. So, is it even reliable now? How long can you keep using it? When should you perform maintenance? And all of those things becomes important when you go into that topic. Okay. Okay. So, any question until now? Audit policy, yeah, it was there, right? I forgot to mention, I think. Where is it? Oh, next page. Yeah, it is there. I forgot, right? So, in case you decide to audit, you have to passing grade is 40%, that is usual, but the other part is not usual. So, you have to submit at least 2 homework, submit what marks you are getting, I do not care, and complete the term project. For audit? No. Now, why complete the term project is there? I will tell you. Because you are working with someone, right, for a term project. If you live in between, your partner might suffer. That is something I do not want. So that is why this I have added based on my experience the first time I taught machine learning. So, yeah, so that part is, yeah, so that is because of that. Okay. Any other question? No? Okay. If I was taking this course, my strategy will be to, I would have focused on the first two, by the way. I mean, that would have been my strategy. Okay. Because if you focus on first two, the remaining two you will anyways perform very well. Okay. Specifically, if you focus on the first one, then the third and fourth one you will perform anyways very well. But yeah, but if you only target the third and fourth one, which is reading one day before the exam, you might or might not do well in that, but definitely will not do well in the others, and that has 30% weightage and 30% weightage. Okay. The other reason I would have focused on the point number 2 is because that adds into my CV. as a project I have done, which I would have, I generally suggest that you create a GitHub page out of it and then put that link into your CV, so that your chances increases, right? It's an opportunity in that sense. But that would have been my strategy. You can have your own strategy. I am not forcing anything. Okay. Any other question?
About the last time, I had another class from 11 to 12.
On
Thursday.
So this is from 12 to 1.
That is from 11 to 12.
11 to 12 on Monday and Wednesday.
And only Thursday is.
Thursday is 12 to 1.
No, I have another class. Class is clashes with like 11 to 12. It's 12 to 1.
So there is no class. 11 to 11:50 is the actual timing. So 11 to 12 on all 3 days. I doubt.
No. On
Thursday, right?
Thursday.
So that is actually 11 to 11:50. You have 10 minutes time to come here. Okay, that is not 11 to 12. This class is not 12 to 1. This is 12 to 12:50, right? That is the actual timing. 10 minutes is given for you to go and for me to come early and set up my laptop. So the actual class timing is 50 minutes or 1 hour 20 minutes. And these are the 2 slots ideally has. It is not 11 to 12. Okay. So I will repeat. Some of you came late. I started with 2 things. So let me repeat that before I move on to some basic things. The first thing I told was that you are only allowed in the class. Today I allowed it, but obvious reason. But from next lecture, only up to 5 minutes from the class starts. So the class will start at 12 or 11, depending on which day you are in. So that means you are only allowed up to 11:05 or 12:05. Don't bother to enter if it is 11:06 or 12:06. I will not allow. You will not miss out on anything because the videos are being recorded. It will be uploaded. So that you will not miss out. That I can promise. But you will not get attendance. That was one part I talked about. The second thing I think I talked about was the attendance policy, which is we will follow just the institute attendance policy. Nothing special from my side. I think for taking attendance they have started something. I have to figure that out. Some something they have. So I have to figure that out. So today there is no attendance. That means everyone will get attendance. But from but before next lecture I will figure that out. Okay. I think these are the 2 things I talked at the beginning, right? Anything else? No, right? I think these are the 2 things I started with. Yeah. One more thing. Let me talk about this website. I told you. This is the website, but this is not yet updated. So I will update it by the end of this week. So I did not get time. So I did not update it. And it will be slightly different from the last time I taught reliability, which was 3 years ago. So there will be some changes. There will be many common things, but some things will change. Okay. So now I have 10 minutes. Let's say 10 minutes is what I will do. Because I have 10 minutes, maybe let me not write. Let me directly go to the slides. I generally prefer to write, so I will mostly the lectures I will be writing. Okay, but today I am not doing that. And then you will have slides like this, okay, which is for your own reading. I will not go through the slides. So first of all, this course is on reliability. So can you think what is reliability? What do you mean if I say someone is reliable? What do I mean? Trust. You can depend on that. But how do you build trust in a world that is not certain? Right? No one is certain. If I ask a friend to help me, he might help me 5 times, 6 times he might not help me. So how do I decide in a world that is not certain? And world is not certain. So then how do you trust or build this trust, or how do you know someone is reliable? Probability of success, right? So that is what it is. In view of uncertainties in the problem, satisfactory performance cannot be assured. There will be failures and then there will be successes. So that means you have to start thinking in terms of probability. And instead of assurance, so therefore assurance can only be given in terms of probability of success. Probability of success of what? Certain criteria. What is that criteria? That if there is an earthquake, this building will not fail. That means I trust this building, and that's why I am sitting here. If I tell you this building will fail at an earthquake of magnitude 3, you will not sit here, I will not be here. That means I don't trust it, right? So this assurance can only be given in terms of probability. And this probability of success in engineering terminology is known as reliability. And this reliability will not see there is no concept of time in this, right. But if I go to system and if I go to actual engineering system, then the time aspect will come into picture. Let me tell you how. So, when I design a building or a bridge, I design it for a certain life, that the bridge should be working for 20 years. So, that means I will call the bridge is reliable if it satisfactorily performs its desirable function for that period. And satisfactorily performing the desirable function, that will be in terms of probability. And this probability will not be a constant now, this will change with time. Initially it will perform satisfactorily maybe 99% of time, but towards the end it will perform satisfactorily maybe 95% of the time. We might have a threshold that as long as it is more than 90%, it is doing well. So, then that becomes reliability, where the reliability is now changing with time, and that is the most common problem. Everything has a life attached to it. In fact, that is the difference between engineering. I mean, there are some buildings, right, let us say in the Mughal era or even before that, which are still standing, but will you call it engineering? Most probably no, because engineering means you are designing something to fail when you want it to fail. So, that means when you design something from engineering point of view, you optimize it, and you optimize it for a certain period. Just increasing strain without worrying about cost, then everything will stay for everything. That is not engineering by the definition. Engineering is inherently associated with optimization and safety. So, keep that in mind, that everything that is designed for a period, and we design it for a period, and the idea is that after that we should either repair it, retrofit it, or abandon it. So, that is the idea, that should be very clear in your mind. Okay. So, engineering design means you are designing for a given objective. Okay. Now, why is this course needed? Because reliability, probability is new, and as I said previously, these things were designed, but they were designed, or even before reliability, usual design is based on some ad hoc partial safety factor. For example, the load is coming, let us say you calculated that, okay, this load is 5 Newton. You say, okay, 5 Newton, let me design for 20 Newton. So, my factor of safety is 4, and I will design for it. So, then obviously it will work perfectly, it will not fail, but is it economical? It is not. That is the problem. So, you want to design it where you are controlling things. You are controlling the period for which it should work, you are controlling the safety factor you want, or the probability of failure you want in this case, right. So, basically it is all about balancing cost and safety. You want to balance cost and safety. You do not want to make it too safe, so that the cost skyrockets, right, and you do not want to make it so efficient that it fails. So, it is a balance that you are looking at. And as I said, the idea of reliability is coming because the things are not certain, things are uncertain. You cannot predict when the next earthquake seismic load will come, you cannot predict when the next some cyclone might come, you cannot predict all of those things, right. In fact, you cannot predict, okay, let me put it this way, right. Suppose I give you a steel rod and I want you to quantify the elastic modulus of the steel rod. You can do experiment and quantify it, but do you think that is correct what you are getting, or that is there is some inaccuracy there? And not only that, you will get one number, right, but do you think each point on that is having the same elastic modulus? There is variation, right. So, no, even the things that you think are certain are not certain, right. So, there is noise and there are limitations in our measurements and all those things. So, there is uncertainty which is inherent, and there are uncertainties that come into picture because of our assumptions. So, that means I talked about two types of uncertainty. One uncertainty that is inherent, that even if you want you cannot reduce, like the uncertainty in quantum. Quantum is inherently uncertain, you cannot reduce it, right. But then there is uncertainty which is coming because of your assumption. For example, plane section before bending remain plane after bending. We assume that, the material is isotropic and homogeneous. We assume that, and then we come up with theories. We come up with Euler-Bernoulli beam theory. But is that assumption even true in the real world? It might be up to a certain limit, but if it is not, and you are making that assumption, that's an uncertainty you are introducing. And that uncertainty you can reduce by not making those wrong assumptions. That is the second type of uncertainty. So, the first type of uncertainty is known as the aleatoric uncertainty or irreducible uncertainty. The second type of uncertainty is known as the epistemic uncertainty or reducible uncertainty. Epistemic uncertainty can be of two types. One is modeling uncertainty and one is because of limited data. Ideally, if I can collect infinite data, the limited data uncertainty will go away. Okay. So, these are the uncertainties. Now, I talked, so what are the steps in reliability analysis? First, you need to identify the source of uncertainty and you need to quantify those uncertainties. How will you quantify uncertainty? In terms of probability density function or probability mass function or sometime interval. That is the first step, quantifying the uncertainty in the input. So, that is actually step 1 and step 2, to be very honest. Step 3 is you will want to propagate that uncertainty and find the uncertainty in the output. So, step 1 was finding uncertainty in the input, step 2 is finding uncertainty in the output. And then once you have found the uncertainty in the output, then you will come up with some function which will, and based on that, which is known as performance function, and based on that performance function you will quantify the reliability. I will give you an example. Think of a cantilever beam. The load it will experience can be uncertain, elastic modulus can be uncertain, area or cross section can be uncertain, right. So, these are your input uncertainties. You find their PDFs. Okay. Now, I want to calculate the moment, bending moment, and the deflection. Let us say only deflection for now. Deflection is find of all of those things, right? EI by LQ and then some factor will come, right, if it is cantilever. So, now actually PL by 3EI, to be very honest, or anyways. But anyways, so that is the deflection. Now, because E, I, L, all of these things are uncertain, your deflection is going to be uncertain. So, that is the uncertainty in your output. Now, with the uncertainty in the output, you want your cantilever beam to be safe. You know that if deflection exists certain value, it will fail. So, you have the PDF. Now, you will come up with a threshold that what is the chance it will exceed, let us say, certain threshold. And if you calculate that, that is your probability of failure. 1 minus probability of failure is your probability of success reliability. Okay. And then you can come up with some index, standardize that and all those things. So, I will repeat. First step is find out which variables are uncertain. Second step is quantify those uncertainty. Third is propagate those uncertainties. Fourth is now quantify the propagated uncertainty. Fifth is quantify reliability. These 5 steps, and then there can be sixth one, design. Clear?
So, you are modeling the uncertainty of inputs. So, given the uncertainty of inputs, we are trying to find out the uncertainty in output.
Output.
If there is no uncertainty in input,
then there is no uncertainty in output, then there is no need for reliability.
Modeling,
right? That is possible, but in reliability, in most of the literature, 95 to 98% of time, we try to quantify the uncertainty because of the aleatoric. These inputs are the aleatoric uncertainties. We want to quantify because of that, and I will tell you the reason. Generally, if you look at the uncertainty, you will realize that the uncertainty because of this load, this material property is much higher than the uncertainty because of the model, until and unless you are making a blunder. And that is a blunder, that is a mistake, that is not uncertainty in that case. So, that is one of the primary reasons. But you are right that if you know that the modeling uncertainty is there, then you should quantify the total uncertainty and then you should find out the total reliability. But finding out reliability only because of modeling uncertainty is not done, because that is so, and probability of failure will be 10 to the minus 50. So, that is as good as not having a reliable, it is totally reliable, right. So, that is the reason you can and you should if you know, that will have a significant contribution, but if one is 10 to the power minus 5, the other is 10 to the power minus 50, then you know you can ignore that, right. So, that is how it is. Okay. So, very quickly we will be talking about, mainly majority of the course will be about 3 kind of techniques. The first one is Taylor series based approaches, which is form, sum, and this diagram kind of depicts that, where you will kind of try to find this beta you see, and we will talk about it in details. I am not going into details right now. Okay. The second thing we will be talking about is about sampling based approach. I have given you one example of Monte Carlo integration. We will talk about it in details, but fundamentally it is very simple as finding out ratio of failure by safety, or ratio by total experiments. I mean ratio of number of failures by total number of experiments, as simple as that, right. And we will talk about different techniques, and this is, by the way, is probably the most accurate one, but it is never used because it is so expensive, and I will talk about that why. And lastly, we will talk about machine learning surrogate model, what you call it, where we will use machine learning as a surrogate model to replace this expensive simulators and quantify reliability of a system. And I have again given some examples here. Okay. So, this is kind of the overview that you will see in this course, right. So, in the next lecture I will forget about all of this and start with basic review of prob and stat. We will start with that. We will spend probably the whole of next week and even maybe the week after that on reviewing that, and then we will go into actual reliability stuff. Okay. So, I will stop here. I thought I will finish early. It is 1:50, 12:50. Yeah. So, thank you. Any questions? If not, I will stop here, right. And if the classroom changes, which I hope will, I will communicate the same. Okay. Thank you.